Let's do it on this sideboard over here. Yeah. And let's zoom in. This thing is starting to get mank. I need to reduct tape it, I think. Or get a real stand, you know. I'm on a budget. There we go. Oop, maybe not. Down. Zoom. Oh, that's gorgeous-ish. Okay, so here's what we're going to do. We're going to slap a dot plot and a box plot together. So the first thing we're going to do, and sometimes these are called box plots, sometimes these are called box and whisker diagrams. What's that?
Oh, just the whisker thing.
Yeah. Well, you'll see why. It looks kind of like a cat's face when you finish it all off. It's kind of like a kitty's face. So, which is what woke me up this morning licking my face. So the first thing I like to have is a scale. So since we're talking about number of states visited, and we went to 28 maximum, correct?
Yeah.
So why don't we just go 0 to 30? How's that sound? No need to go up to 50, I don't think. 0, and then just cut it up by 5s, 10. Your TIs do this, and we'll show you how momentarily. Further, I guess, 25, 30 up there. Anyway, break my face. You actually sit down in class? And now we just add the box plot by drawing the 5-number summary. So you got a bit of a sneak peek when we had the exam grades up there. There's a box around the middle 50%, and the whiskers go out to the extremes. So you put little tiny endpoints at the 5 and the 28. That would be your min and your max. The min and your max. You put slightly longer lines at the quartiles, the Q1, Q2, and Q3. I've noticed your textbook puts a dotted line at the median. You don't have to. There's no hard and fast rule for that. I put solid lines on all 3 of them. So that would be 11, 13, and 23. So 11's here. 13's going to be like here. And 23's over here, right? Oh yeah, this is freaking awesome. Your box is formed by joining all those guys. And then your whiskers come out like this. It's a straight line. That's a box plot, or a box and whisker. How is that advantageous over just simply having the 5-number summary in front of you? Remind me again why we like this a little bit more.
Makes sense.
Because it looks like a cat? It makes more sense?
Visually.
Visually, tell me why.
Because you can actually see the distance.
Yes, I love that. I love that. We can see, Shelby, right? Mm-hmm. I love the fact that we can see the distances in the ranges. Look at the data, how tightly clustered it is right here versus how spread it is right here. Now some of you are saying, Rule, I don't see data at all. There is no data up there. Good, we have a fix for that. Let's add the data to it. We actually, now sometimes you can't do this because the people won't give you the actual raw data. I had this discussion just 2 hours ago with Bruce Emerson. You may have had Bruce in physics classes here. He's trying to collect data from IR, which is the folks that collect data down here, but they keep giving them these things called moving averages. Does that sound familiar to you? Moving averages. Why do we like moving averages? What does it do? It's right, you look at like over 3 years versus year. And why do you like that? What does it do?
Test cycles of information over time.
Good, but why not just check the average every year rather than every 3 years?
It shows trends.
It shows trends better necessarily than individual years. Why? What gets smoothed out?
It's more long term, it's not more short term.
Good. You got the goofy short-term hiccups get smoothed out. You can focus just on the trends. What you guys are saying is correct, but it removes all those goofy spikes that sometimes happen. So if you have an outlier year where that will be mitigated somewhat by a moving average. Anyway, the point is that he didn't have anything to the moving averages. So the data was hidden from him, and that often happens. We get the result of an experiment given to us in graphical form like this. Sometimes that's as good as we can do. And in your homework, you'll see some problems where you have to compare box plots, which is definitely worth doing. We'll do that momentarily with some data I'm going to have you guys collect. But let me see if I think I still have your guys' data. Your guys' min was 5, right? 5 and 11. I think you guys are over here. Okay, let me make sure I got this right. There was 1 5. There was a 6. 6 right here. There was a 7, yeah? 10, 2 11s, 2 12s, 3 13s. That was your median, correct? Yeah. Mhm. I got 1 14, a 16, a 17, a 20, a 22, this is 23, correct? Two 23s, a 24, and 3 28s. There were 3 20s. There were 3 of them. Which that drives the percentile down even worse, down even more, doesn't it? Good, we'll come back to that. That's good. Okay. Now, what's the advantage to having the dot plot with the box plot? What's the advantage there?
It gives you the raw data.
Now you got the raw data, which is always a good thing. Raw data is always better than not having raw data. But now, anybody who's sitting down going, what's he talking about? It's more variable if the box is wider. Now you can see that it's more variable. Look at that the wide 75th percentile down to the median, right? Look at where all the data is. It's scattered like buckshot throughout the entire thing. But look at it in here. It's all stacked up on top of each other. So when you think about the histogram that's in here, and then a little goofy little thing over here that I never would have predicted that at all, honestly. I forgot that we had 3 28s. But I love that. How many data points are there all together? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22. 22 of them. The median is going to be directly in the middle between 11 and 12. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. There's your 11, right? And then your 12 over there. There's your median. Boom, centered. The quartiles are then going to take each of those 11s and knock them in half. So you're going to take the 11, cut it in half down to your 5, and you're going to take the 11, cut it in half down to your 5, and there's where your quartiles are. But look at the spread on the top half of the data versus the spread on the bottom half. Now when I say top half and bottom half, in the absence of raw data, I have no idea how many students are represented in this chart, do I? I just know half of them were to fewer than 13 states and half were to more. That's all I know. But with the dot plot, you also get that frequency attached to it too. So you get some shape, you also get some idea of your sample size. It's just more information, better information. So, you guys find your data point and tell me your percentile. Find your data point and tell me your percentile. And I'll turn the camera off, so it'll take some time right now.